In this video, we will learn why Wi-Fi scan is required. What are different types of scan? We will see few Wireshark examples. And at last, we will see how scan result looks like. So why Wi-Fi scan is required? Wi-Fi scanning is the process by which a Wi-Fi device, like a printer, mobile phone, laptop, or router, searches for available wireless networks within range. This scan helps the device identify nearby access points, gather information about them, and ultimately allow the user to choose a network to connect to. Let's understand how Wi-Fi scan works. There are two types of Wi-Fi scan: active scan and passive scan. In active scan, the client device searches for wireless networks by transmitting probes and listening for responses from the access points in range. These responses describe the configuration and capabilities of each of the wireless networks managed by the access point. In passive scan, the client device listens for beacons, which are specific frames transmitted by the access points to announce their presence and, similarly to a probe response, also include the configuration and capabilities of the wireless networks they service. A client device must listen on a channel long enough to catch a beacon from a nearby access point. By default, beacons are transmitted at a rate of approximately 10 per second. In active scan, there are two types of scan: undirected scan and directed scan. In undirected scan, station broadcasts a series of null probe requests on each supported channel for both the 2.4 and 5 GHz bands. A null probe request does not target any network in particular. Thus, all access points that receive the probe request must send a probe response for each of the wireless networks they manage. Response frames are sent directly to the transmitter of the probe request. Probe requests are sent to broadcast address. Once a probe is sent, station starts a probe timer countdown and wait for answers. At the end of the timer, station processes the answer it has received. If no answer is received, station moves to next channel and repeats the discovery process. Let's look at Wireshark packet for undirected scan. On the left side, you can see example of probe request. Probe request is management type frame. It is sent to broadcast address. As this is undirected scan, that's why SSID field is missing. On the right side, it is the response packet for the probe request. This packet is called probe response. It is also of type management frame. In probe response, you can clearly see the SSID field contains actual value of SSID of access point. Let's jump to directed scan. Directed scan mode is just a type of active scanning where the probe request frame includes the name of the target network. This mode allows you to scan for a specific hidden network, or any network for that matter. The mechanism to perform the scan and to process the results is exactly the same as in the active scan mode. Let's explore Wireshark for directed scan. Probe request for directed scan is similar to undirected scan, but it contains SSID field. That's why it is called directed scan. Okay, we now know something about active scan. Let's learn about passive scan now. During passive scan, device detects available wireless networks without actively transmitting any request. Instead, it listens to surrounding environment to gather information. During this process, devices listen to beacon, which contains SSID, BSSID, supported data rates, encryption types, etc. In passive scanning, Device is placed in monitor mode, which allows device to listen. The scanning device can hop from one channel to another to capture beacons from different networks. Let's check the packet structure of beacon frame. It looks similar to probe response only and of type management frame. It is sent to broadcast address and contains the SSID of access point. This is how the scan result looks like on most of the devices. This result is from undirected scan, where you get all SSID available in the vicinity and can choose the one which you want to connect. In next video, we will learn how connection happens between station and access point. Thanks for watching and hope you had great learning from this.